Good evening to one and all present here. Am I audible, Santosh sir? Am I audible? Yes. Yeah, good evening to one and all present here. I am Priyanka Pandya on behalf of GSFC University. Welcomes you in this fourth session of webinar series Strikes. And today we are going to discuss about the topic that is robotics. And since we are having the different participants for all the sessions, I would again like to give you a brief of GSSC University. That GSFC University is basically a CSR initiative, that is a corporate social responsibility initiative of GSFC Limited, that has been uh, founded in the year 2014, and since then we are approaching to the with its all the USP at its best with three schools, that is School of Management, School of Technology, and School of Science. GSFC University has its vision of to strive to the best compact boutique institution with the futuristic approach, encouraging student-centric culture and the sharpened focus on developing industry-ready and employable students with all-round development, and the mission of establish an institution which promotes creativity as well as innovation, and to develop unique quality standards for academic excellence and pedagogical innovations. So, our university in all the three schools having the faculty with industry as well as academic experience. And today, for this robotics session, we are having the speaker of the day, Dr. Manish Kumar Gupta. So I would like to introduce him to all of you. He is Dean Students Affair and Assistant Professor in Physics. He's also the member in IEEE, International Association of Engineers, and IDES. He is also the life member at Rajasthan Physics Association, Vigyan, Gujarati. And his area of interests are, of course, robotics, data science, industrial automation, biomedical electronics, and many more. He has also published one book chapter in Springer Nature Singapore, and two books in the press, that is under Arihan publication. And he has also he has also filed one Indian patent for by his name. So I would now request Dr. Manish Gupta to take over the session. And once again, I would welcome all the participants and faculty. And now I would request Sir to just initiate the session. Thank you, everyone.
Thank you, ma'am, for such a nice introduction. And the talk of today's topic, which we are going to discuss, that is robotics. So let me start. What do we mean by robotics? Because it's a vast area and vastly known as an quite interesting field for the students. Most of the students are studying in science. They find it fascinating to go through this kind of terminology. So what we are going to cover in today's lecture, we are going to have a complete detail and a complete overview of the robotics and the origin of robots, means how this terminology came into picture and what do we mean by robotics, what are the scopes in that, and what are the threats in this field. And we will discuss in that particular point of view. So let's start our today's presentation. So for an introduction, the robot have become a subject of great interest for all. Everyone who belongs to science, he used to find himself connected with the robotics in one or another way. In last day, we had lecture on 3D printing. That is again somehow the part of robotics only. By virtue of our imagination, normally what we imagine by a robot looks like in our imaginations, like something very similar to human being, which can perform the task like we see the movie Transformer in that way. And there are some robots which looks like human. We call them humanoid, but not at all. All the robots are something which are a duplicacy of human, or which can be compared with humans. There are varieties of robots, so we will see that, and what where from where this term has actually appeared, the robotics. We will see that. So the robots are basically a device, a mechanical device. So the important thing is the robots are basically a device made by men, most of the time programmed, and programmed for what? Programmed in such way that they can move by themselves. Their motion and their movements, they are always modeled, they are always planned by some human who is programming for that. They are always sensed by some particular object for which it is planned. They are actuated. There are some inbuilt components, hardware, which are actuated on the basis of that. And most importantly, they all can be controlled. If you focus on this definition, you will find two, three big concepts. The first one is all the robots are ultimately some mechanical devices. The second one, they are well programmed. And the third one, they must be controlled. On the basis of these three things, the robots are made. Now, robot is always made for some specific type of application. In comparison to human brain, robot have very less uh, power, or very less limitations to do the things. It always programmed to perform some limited operations, while a human can think marvelously and can perform n number of things at the same time. He can think of n number of things while robot cannot. So a robot is basically a machine, a mechanical device. If I go through this all, simply I can understand that any robot, to understand any robot, basically what we need to learn, we need to have some basic strong knowledge of foundation of mechanics, for sure. That's what we have learned in class 11th. Now we need to have some basic idea of programming. It's not too hard to learn. And the third thing is, to understand the role of sensors and the actuators, we must have a good knowledge of electronics too. So the robotics is a mix and a great combination of mechanics and electronics along with programming. So how it is and how it happens, we'll see that in the upcoming slides, right? So what is robotics? So robotics is basically a science which is used to design or build different type of robots. And each robot is specified for some kind of application. So ultimately, robotics means to work on that particular requirement, that for which particular application we want to make our robot, then to analyze what kind of components or what kind of design we should prepare on that, and finally to make it. This all in combination is known as robotics. Simply, if I simplify the things, then the robotics can be simply defined by study of robots. Study of robot means the requirement, the application, and the working of. The aim of robotics, that is the most important thing. The aim of robotics is to design an efficient robot, right? So here in the animation which is running here, you can find one robot. So this robot which is here do not look like in anyhow to the robot similar to that robot which is there in our imagination, that a robot like we saw in the Transformer movie series and all. The robot is anything which is a mechanical device. You can see here we are using mechanical device, and then there is some operation which is assigned to it, and it is supposed to perform that operation. And if that is being done by any kind of machine intelligently by itself, this machine is known as robot. So So robots are intelligent machines who work depending upon their programs, right? So do we actually need robots? We'll see that. Now, by this definition and by the understanding what we have developed till now, we can focus on certain things. The first thing, robotics can be defined as a combination of two different parts of physics, and that's why physics faculty is teaching you robotics here. So one is mechanics and another one is electronics. And again, in electronics, there are two parts. One is hardware, another one is software. That means the programming. This all in combination are required to create, to make a basic robot as well as a very advanced level robot. So robotics require the basic knowledge of these things. If you are looking to pursue your career, or if you are willing to be good in robotics, your fundamentals of mechanics and electronics, whatsoever you're studying in class 11 and 12, that must be quite strong. If they are not, please do it. Now, do we need robots? Yes, of course, we have seen good number of robots now here and there, and they are there somehow integrated in our life, knowingly or unknowingly. But do we actually need that? Yes, there are certain reasons why we need robots. The first reason, very first reason, is speed. The robot speed is something which is unmatched with the human being. See, when we talk about human being, we perform n number of tasks in a day. That's why we are not as perfect as a machine can be. We get tired, we need to take rest, we need to take salary to do something, we need to get compensated for something. Robot do not want anything of that at all. We get bored when we do repetitive tasks, and robots are something which can do anything n number of times and without taking any rest. So whenever we need to work in some kind of hazardous situation or dangerous situations, the human being are always having some kind of sensitivity with respect to the hazards and dangers, while robots can perform that task. The another thing is they can do the work repeatedly tasks. They can do it n number of times. There is no time lagging in their work. They work with accuracy. The accuracy of robots is quite good. If the programming is done good, and if we have good quality of sensors and actuators, then the robots works actually good. And they are working, and their efficiency, that actually makes them very much useful, right? So we need robots, and that's why robotics market is taking place and growing nowadays. You see this video which is shown here along with this slide. Assume that just imagine it that there are three persons who are supposed to hang like this in the air and supposed to perform some certain task which is given to these robots. And you can imagine that how boring and how tired it is going to be for them. For robots, it's endless task. They will do it n number of times. They will perform it. Now, the history of robot. It was Carol Capek, who was a Czech person who first time introduced the word robot, who made the first word robot, and this word was actually taken from the Czech word that is basically means to force the labor which is forced to do something. You can compare the robot with some kind of forced labor in history, which you see in some kind of movie. They are forced to do the task, even they are if they are tired and they are not having any kind of energy, but they are supposed to perform that task. The similar thing is there, and the beauty of the robots are that they need only power supply, as in the form of their salary or their food or their tiredness. They don't need anything else. If they are having adequate power supply and they are programmed good, they will be keep on performing. The word robotics was first used in Runaround. It's a good story that was published in 1942, and it was made by the story was written by Asimov. In 1956, it was the time of Second World War when the first robot came into existence. Though in our movies, if you see the Hollywood movies, the robots exist even before that time. So there are certain laws of robotics when we make a robot or when we work on some robot as an engineer. There are certain laws which are performed for robots and which are actually even made learn to robots too. And they most of the interactive robots, they understand these laws in one form or another. And these laws are very similar to thermodynamics. These laws comes in the picture, like first law was introduced first, second law was second, third law was third, and zeroth law was introduced at the last. The first law says, and all these laws are focusing on the same thing if you will study them. The first law actually says that the robot may not injure a human being. It should not allow a human being to come into harm, and this situation should follow until unless there is a violation of higher order law. That means higher order law for first law is second order law and third order law, right? The second order law is the robot must obey order given by the human being. Whatsoever the his command has given him some order, it should follow, except such orders violate or conflict the higher order law. Again, the third law says that the robot must protect its own existence as long as such protection does not conflict with higher order law. And the higher order law, then the third order is actually the zeroth order law. And the zeroth law order is most important law, that the robot may not injure humanity or through inaction allow humanity to come harm. That means the robots are made not for human, they are made for humanity. Right. So by any virtue of operation or any virtue of thing or by any reason, the robot should not harm the humanity. So these are some laws which are followed in robotics, and every robot is supposed to follow these laws, right? So let's move next. The first robot was made, as I earlier said, during the Second World War in 1956, and this was named as UNIMATE. Here is a picture of original robot of UNIMATE. This was made by US, and there was one company named Kawasaki involved in the production of this robot. And this robot was designed by a firm named Unimation. This firm was owned by Josie DeWalt, then Norman Schaeffler, and then Joseph F. Engelberger. Joseph F. Engelberger was the major contributor in this development of robot, and that's why this person is referred nowadays as a father of robotics. So fine. This is about the first robot which was made, and see, the first robot itself was something not like that transformer kind of robot. Okay. Now the robotics technology, there are some certain components in the robotics or the robot or in the robot which always uh, found there as an essential part of the robot, and these components are now defining here. The most of the robots are having at least these following parts. The first part itself is the manipulator or rover. The manipulator is known as the main body of the robot. That means all kind of links, joints, and all other structural elements which are there in that robot, they all come into that part. So whatever we have as a structural element in this particular robot, this all is basically manipulator or rover. Then there is one second part named as end effector. This part basically identifies which is actually the last component of the robot, which is the last component which is supposed to be controlled by some kind of program in that particular robot. That last component is separately defined in robotics. The part that is connected to the last joint hand, that is known as end effector. If we move further, then there are certain more components. There are some actuators in a robot. Actuators means whenever we have some kind of situation or some input, on the basis of that input, the program which we have made in that robot or in that programming, that allows robot to execute something, to do something. and that execution or that doing of work is done by some kind of actuators. Like there might be some kind of motor, there might be some kind of hand of a robot which is moving from here to there for some purpose of work or something. So these all components which act on the basis of some actual signals are known as actuators. Now, we need another component which can sense these kind of inputs. Like let's say we have a robot which should respond in situation of rising temperature. So there must be some kind of sensor which should sense that temperature first and inform that program, that basic computer inside that robot, that there is something in temperature which is now being changed, and that's why we should perform. That's why actuator should get active. So that part is done by the sensors. So these two are basically electronic component, and these two are very important things in robotics. So while we are studying robotics, while we are going through that, we must have good sound knowledge of actuators as well as sensors. So we have a robot here. You will see that there is one arm of that robot which is actually moving and detecting something. And on the basis of that detection, there is some sensor who has detected this particular part. On the basis of that detection, actuators are being active and they are performing their task, the task which is programmed inside this robot, right? Now there are two more things in every robot. One is controller. Controller is basically a small processor like CPU of our computer. That controller actually do that all task. Whatever programming we make, that is get stored in that particular controller. Then we have a processor there. That processor is the brain of that robot, which actually calculates all kind of motion. It's like ALU, again, ALU kind of thing of our CPU. So it calculates all kind of motion, then the velocity of the robot joints and the movement of that arms, and everything is done in the processor. And accordingly, the commands are given to the actuators. Now, the another important part of the robot is a software. The software is basically the operating system. On the basis of that, we are developing our code, and we change the operating system, their language and their programming code get changed. So we need to learn the adequate software which is useful for our robotics programming. Normally, for the basic robots, Arduino programming is being used. Arduino is very similar to C language, and C language is the base. If we know C, then obviously we can work on any language whatsoever is given to us by some small efforts to understand it. The failure of software may lead to various number of problems. And see here, we have one animation again here in this diagram. If you will see it, then you will find it that even a good programming in robotics, if not meets considering all the constants and the environment variables, then sometime leads to failure. You will find here that the robot here is a scene of RoboSoccer, the word RoboSoccer League, right? So the RoboSoccer is supposed to kick the ball at this time, and because of some environment variables which are not taken care in the programming of this particular robot, so it's not able to do it. So that's what all about the components which are there in the robotics technology and which are used, which are required to understand or to design a good quality of robot. So let's move further. So the robotic structure design, when we design any robot or any structure of a robot, then there are some certain things which should come in our mind first, and then we should look for the design. We should start with some kind of questions with ourselves. And on the basis of that only we go for the design. And the questions are very obvious one. The first question and the very first question is utility. We must know that what kind of utility is going to be there for that design which we are making, because ultimately a robot is supposed to perform some certain work with number of efficiency. If it is not able to do so, then the creation of robot is not worth at all. Then there must be some kind of creativity. Creativity may be in terms of new functionality, it may be in terms of new speed, or it must be in terms of new durability and all. So there must be some kind of creativity when we design some robot. Yeah, for initial purpose or for learning purpose, we always study and we design whatever is always existing. But ultimately, as in robotics engineer, when we grow, we try to design something which is till now not available, or at least not available with efficiency. Right. If you'll see, then you'll find in recent news that in the current situation of COVID-19, there are robots which are doing good work in many countries. There are robots which are helping police. There are robots which are helping in medical sector and all. And they are actually working in those critical areas where we cannot afford to cost the life of human being. Now, another parameter is stability. The design which we have done and the programming which we have made, how good stable it is, and up to how much time it can keep on going. That hardware might have some kind of limitations, right? When, let's say, and robot is supposed to perform in high temperature, then its hardware might have certain kind of limitations that after some certain time its hardware might need to be replaced. So stability again becomes some kind of important issue. Then in design, because there are various types of robots available, we will see next. So there is another thing, to make a robot actually movable, we need to focus on center of gravity. Center of gravity is something for any body, for human body even, which decides the movement of that body, right? We have studied this all in class 11th. So center of gravity again becomes something important. It's about mechanics only. Then there is rigidity, how rigid is it going to be? Then there is durability. These are the points which we need to focus before we start our design. So these things actually makes our conceptualization strong, that whatsoever we are planning to design, that is going to be somehow useful, somehow good, and somehow actually something which is required, right? So these are basic robotic structures. So now let's focus on the types of robots. There are variety of robots available, and broadly they are categorized in four. I have included five here. So they are broadly categorized as in mobile robots, and the beauty of these names is that by name itself you will understand quite a lot. So the mobile robot is something which is movable, which can move from one place to another place completely. The industrial robot is something which is used in industry. Right, we'll see in detail. The autonomous robot is something which do work by itself without any command further. Once it is programmed, it will work itself. The remote control robot is something which can be controlled from remote areas, and which can be controlled from remote by its programmer. And the virtual robots are something which actually do not exist. We will see it. What does it? Right. So there are some certain categories of robots, and uh, by going through this category, you will come to know that robotics is quite a vast area. There are very good number of possibilities of career in the robotics, and you can learn a lot during your graduation, and depends a lot that from where you are pursuing your graduation, because these kind of exposures are not available at everywhere, right? So let's move. So the mobile robots, there are two kind of mobile robots in broadly definition. One is rolling robot. Mobility from one point to another point of a complete system can be done in two different ways. One is rolling, and another one is walking. Rolling means there will be at least two tires, or there might be four tires, three tires, different kind of tire system on, and there will be some kind of motor which will be actually moving that tires, and because of that, that movement will be done. So you'll see in this diagram there are this diagram is from a RoboWar. This is a typical competition which is most of time held in many of the engineering colleges and universities. So there are two robots which are fighting with each other. Is very much similar to mixed wrestling. Then the second diagram here in the right side, you will find here that there are some walking robots. Walking robots means there must be at least 2 legs or 3 legs or 4 legs. And while using that legs, the robot is walking from one place to another place. The most fascinating walking robots are inactual. They are available in either in the form of humanoids or they are used in RoboSoccer, RoboSoccer League. Japanese are working on this a lot. So fine, let's see this again. The rolling robots. These robots are having some tires and they can move from. They can move. They can turn around. They can go front and back because motor can move in both directions. Depends upon which kind of motor we are using. Then there are walking robots. They can walk from one place to another place. They both are mobile robots. Mobile robots means the entire body of the robot can move from one point to another point. So whenever we have this feature in our robot, that robot is known as mobile robot. Now understand this thing. We have broadly categorized the robots in these categories. It doesn't mean that one robot always belongs to one category only. It might be possible a robot is mobile robot and also autonomous. Might be possible there is one robot which is industrial and autonomous, and any other combination. There might be possibility, right? So it's not always like that that a robot which is available with us that will belongs to exclusively one category which is defined here. It can be a combination of more than one. So let's move to the next, the industrial robots. So industrial robots are something which are always stable. They stay at one point. They are also known as stationary robots. They don't move from their own points while staying on their own position. They have some kind of robotic arms, and these arms only moves, and the movement of that arms is designed such as that they perform that desired operation. Most of the industries they use these kind of robots, and these kind of lines which we are showing there in this presentation, these kind of lines are known as assembly lines, right? So automated assembly lines, further if I correct it. Now you can understand that the center of gravity is quite important. Otherwise, if there is one robot who is not designed well with respect to its center of gravity, then the movement of an individual arm or more than one arms instead of complete body movement might be quite difficult. So COG, taking care of COG, center of gravity, becomes quite important in robotics, right? So these kind of industrial robots, they always perform most of the time repetitive tasks. They repeat their task again and again. Whatsoever we have seen in this video, they will keep on doing the same things again and again without any kind of tiredness, without any kind of complaint, and they will do it. They will do it day and night, 24 into 7. So most of the robots, these kind of robots are working in industry, and especially where some kind of dull works are being done. See, manpower, when a man is supposed to perform or a labor is supposed to perform repeated task n number of time, and this task is dull, then there are huge possibility of errors because the human nature do not like dull kind of activities, right? But these kind of activities can always be performed by robots, and they will do it without complaining and day and night. Fine. So this is second category of robots. If we move next, then there is third category, that is autonomous robot. Autonomous robot, by name, it makes something clear that their programming and their sensor and actuator, they are made such beautifully that depending upon the situation, whatsoever the outer environment is and what they are supposed to do, they they themselves decides that what should be the next step. Imagine that ISRO or NASA is planning to send some rover to Mars. So it cannot be always all the time controlled at Mars from the Earth. So it must have some kind of inbuilt programming or inbuilt capacity to take decision on some particular point whenever it gets stuck. So that's what the beauty of that robotics is. If that program is good enough, then the design is good enough, right? Now, this robot missions, means the Mars rover or any other rover which are sent to other planets, this mission is basically designed for some particular task to collect particular kind of samples or to make particular kind of observations, and for that particular thing only they are programmed that if there is some if and but in surrounding, if there is some kind of situations in the nearby environment, so how they should react, how they should work in that situation. So these kind of robots are known as autonomous robots. Autonomous robots may be uh, rolling mobile robots or maybe walking mobile robots. Autonomous robots are bound to be mobile robots. They are most of the time mobile robots only. So if you see the description here, it's written that they run a program that gives them the opportunity to decide on the action. Now they decided by themselves that what should be done, and this is done depending upon their surroundings. Now, how they actually get that information, what is happening in surrounding, for that they are less with the sensors and actuators. They have all kind of possible sensors which are required for them. They get continuous inputs from their sensors. On the basis of that, their processor actually and controller provides the instructions to their actuators. Okay, this is the situation and this is how you should act now, right? So this is the third category. So for autonomous robots are nowadays self-learning also. They are actually something which learns from their mistakes. So they have certain kind of sample behaviors inside of them. They used to adopt one by one behavior, and they find it that in which one their performance was better. They self-analyze it. On the basis of that, they repeat their most successful routine, whatsoever there was. So what happens actually? A robot is trained in this way. So out of the sequence which are done n number of time inside a robot, in their trial session, it observes, it calculates, and it absorbs the best ones. So the remote control robots. Next category of the robots is the remote control. The most of the humanoid they are made in this category only. And these are the robots which are made for that purpose where there are some dangerous situations and human cannot go there. So robots are there. There are some cameras and some kind of sensor actuators inside it. They see surrounding what's happening in and around, and then the remote controlling person who is the controller actually, it gets all kind of input based on that control rooms persons. They decide it then now what should be done on this particular situation, and that particular information is now shared with the robot from the remote, and the instructions are given from the remote. On the basis of the instructions, it acts again. Right. So recently we had our tech fest here. So we called Mitra here. So Mitra was one of the remote control robot. It's totally indigenous robot, right? Right. The last one is the virtual robot. What does a virtual robot means? Virtual robot do not exist at all. Virtual robot are just software platforms which are used to build robots, used to build their blocks, and these are used to show some kind of interactive structure of that robot. If you use these kind of blocks and these kind of program, then how your robot should look like and will look like. These kind of environments are known as virtual robots. So the virtual robots are something which are used as a simulator, which can actually simulate the real existing robot also, and they can perform the repeating task. So, like we have some kind of smart vehicles and we send them on service stations so they repair it and they service it. Similarly, robots can be serviced by virtual robots. So this is the last category of the robots which we discussed. So we have some certain categories of robots, and it's a vast area. So most of the robot, most of the time, what we know that are mobile robots. We know that line follower, that obstacle detector and all. These are basically the mobile robots only. But industrial robots as well as mobile robots, autonomous robots, a mobile robot made autonomous, they all have great future because world requires them, right? Drone is a robotics technology only, so you all know that how drone is useful, how much they are insisted by government nowadays. So now let's focus on some applications of robotics. So to explore some new, whatsoever is unknown to us, we use robotics. Like space missions, we have already discussed in Antarctic or something where humans cannot stay for more time. Robots are being used for exploring volcanoes. Obviously, human cannot do it. For underwater exploration, on every kind of exploration where human find itself limited to do the things, then robot comes into picture because it can work for you. And ultimately, if you lose a robot, that is better than losing a human, right? So that's why it has vast applications in exploration field. In medical science, there are numerous use of robots. You must have heard about it in newspapers and news channels. There are robots who are working even for surgeries. Okay, they are trained for surgeries, and their applications and their operations are so perfect that they do not make any kind of error. They are doing better than human. They can be guided from remote by some experts, and an expert can be actually utilized at many places at the same time. So in surgical assistance, robots are being very much useful, and the medical science has actually become actually medical robotics. They are using it in great way, right? There are some other examples of robots who are working and were working for surgical parts, and they are doing good. So similar kind of applications, like when we need to deal with some critical things, then the robotic surgery is always treated as a better option if it is available. Mm, there are some assembly things in mechanical factories, in handling and in painting, surveillance, security, and other things. There are some some devices made for home help, and robots are very much useful in that, right? Factories we have already seen, and so robots have lots of application. You can decide your own application. Nowadays there are IoT enabled robots also, so that is remote controlled, so you can find good number of things. Now we need to understand one good thing. Understand this, that let's say we have a washing machine. It has some software inside it, and we have a mobile, and we are controlling this on the basis of IoT. So it doesn't make a washing machine a robot, right? Because of basic definition of robot. If we go with that, robot must be a mechanical device which must be movable and which must be controlled by some external things. So that robotics is something different than normal mechanical things. It's a part of that for sure, but not completely that. So well-guided missiles, when they are launched from planes, the fighter planes and all, the robotics plays role in that. So in defense sector, robotics is quite important. They are working in guided missiles. They are working in surveillance at border areas. They are working in different kind of like weapons which are being made. So they are made in artificially intelligent by the virtue of applications of robotics. So what are the advantages of robotics? What are basic benefit why we go for robotics? That is that we can go as far as we have our limits. We can use robots there. We can go as down as we want inside the water, and we can go for the mines and everything. Then these are the critical places where human cannot go or cannot survive for more time. So it gives us certain informations by sensors and actuators which human cannot gather from there. It works 24 into 7 without any salary or food, or plus they don't get bored also. They can perform their task because they are designated for some particular task. They can perform their task faster than humans, and with much more consistency and efficiency, accuracy. Most of them are automatic, so they can go around by themselves without any human interface or without any human interference. Sorry. So the robots are somehow an intelligent device, and on the top of that, they follow laws of robotics. That means they cannot harm humanity. They cannot harm a human being. Now, what are the disadvantages? Even though we have such strong foundation of robotics, then where is the harm? There are certain disadvantages. For sure, people will lose job because if robot is performing work without salary, then who would like to pay to human? Then they need some power supply, so electric consumption is required for that. Then it need maintenance to keep them running, like as we need to maintain our mechanical gadgets, we need to maintain this too. Then it costs money to buy a robot. You have to spend a lot, right? Depending upon the functionality and what we require from that robot. If it is designed accordingly, you need to pay. So these are the major disadvantages of robotics. That's why it's not as popular as it should be, right? Let us move next. Now, where we see the future of robotics. Robotics will be definitely getting new edge and will be utilized furthermore. Uh, Recently, if you will see, then in the recent future has already come. There are RoboCup which are being RoboCup soccer, which is already being played. It is a tough task. See, to understand it, mm, uh, to recognize our team, its own teammates, to make a goal. You have seen some videos certainly, and you have probably seen that robot get fault. They get fault when they try to make a goal, and to track the ball, and this all is a difficult task to do for a robot. So it has become a great challenge, and people are working on that. So if a robot can play any good live game with the other robots or with humankind, then in that case we will have the next level of robots. So people are very working very hard on it. So this constant advances are being made in robotics, and robots are bound to be revolutionize humanity. So they will work for humanity as they are supposed to, and it will be even in coming 10 years, 20 years, it is going to be a great future in robotics if someone pursue. So this is what we discussed today about the basics and the basic concept of robotics, how robots are, and what robot is, and what do we mean by robotics, and what we can look for, what we should understand with this. So this is all for today's presentation. We are soon planning for a robotics workshop too, and probably it will be planned very soon. We'll let you know about this, and hope to see you there in that workshop. And till then, is thank you from my side. And I would like to have if there is some question from anyone.
Thank you, Manish sir. Yes, sir. We got a few questions in the chat box, and meanwhile, by the time we answer these questions, I would request other participants as well to kindly put your queries via chat section, or you can just unmute your mic.
Mm-hmm.
Yes, sir. So one question is there from Mr. Vikrant, that related to the software. Which software can be used for this, for preparation
So
of robot?
yeah. Yeah, Vikrant. Actually, there are many platforms available. So when you are starting with the robotics, so always go with Arduino. Arduino Uno is the best one kit, and the freeware is freeware, so you can download it from net. Simply type Arduino.cc as the website. This software is free of cost, and there are some inbuilt examples in that. So if you'll go through that, you will learn a lot about what is robotics, right? And The robotics is related to software robot or physical. It's related to both dear. We have already discussed it. A robot have in electronics component two parts. One is hardware, one is software. It means by both. So robotics means a complete pack. Whatsoever is we can design a robot for a small application. It doesn't matter, but it must be a complete pack for that application, right? Suppose I want to develop robot, then which software language can I use? You can go for embedded C, you can go for Arduino. There are n number of platforms which you can work, right? Arduino is the easiest one. That's what I'm suggesting. So
One
there is
more
next.
question from Pramod sir, that is related to like mechanical, since we talk about robotics in the mechanical engineering. So how the performance of robotic system is measured? Is there any defined level for the performance measure?
See, in electronics, it is always that's what the problem is basically because see, robotics is something which belongs to mechanical as well as electronics as well as CS. So the role of each branch or each student becomes important in development of robot. So it must be always a combined team who is working on this, right? Or there must be a person who has at least glimpse of all the fields. So when we talk about the performance of a robot, so in electronics there is always cross check of the design. Whenever we program something, we have fault detection technique. We always design its fault detection code along with the program. That fault detection code is something which is made for critical situations. By assuming some critical situations, we supply input by ourselves and we check how our design is performing, our physical design is performing on that situations, whether it's performing as per our expectation or not. This is how we check the performance of robotic system.
Okay, one more question is there from Pramod sir, like what can be the hazards of using robots? Is there any concept of redundancy in the sensors, controllers, and actuators in robotic science?
Yeah, there is a concept of redundancy, but in terms of hazards, there is no such report of hazards as we have seen in the movie of Robot and so. The only hazard of robotics is that is consuming the job of human manpower. The basic problem with the robotics is when we try to develop a robot, it gets it four, five people, 10 people, they lose their job because robot is more efficient in their work, right? So otherwise, a sensor or actuator, they can't do anything by themselves for sure. Till now, whatsoever is AI or the self-learning process, whatsoever we are using in the robots is been developed, they cannot do anything by themselves. They have always self-learning environment. Whatsoever they will get from outside, they will learn from them on some specific situations. So there is no hazard in that particular point of view. But yes, we are losing the jobs. Persons are already there are already economic slowdown in different parts of the world. So this is what which is actually affecting.
Yes, and I would request Santosh sir to kindly put the link for the feedback in the chat box, and I would request all the participants to kindly don't leave without giving your inputs, so that it would definitely help us to resolve the things if there are any. We got a query from Dr. Mafadla, that is kindly put a light on application of robotics in the development of biosensors and as well as in the drug delivery.
See, sir, robots are something which can be used to perform any automated work where human do not feel safe. As in biosensors and drugs part, I can understand. I'm not so much related, but I can try to connect the things. So whenever we feel that these are some areas where the involvement of human in such kind of drugs development or something can be hazardous, we can replace that particular component with the robots. And robots will do it. They will definitely perform it. There is no rocket science in it. They will do it like other robots are doing. So application, that's what the important concept is. See, now we are discussing about applications of robotics in biotechnology, right? Now, robots are there, they can be programmed for anything, but the thing is, interdisciplinary approach, if it is coming, then in that case, it will make their area more vital and more vast. So it can be planned, yes, it can be planned, but the thing is, it must be properly specified what actually we want to do.
Yeah, one more query from Dr. Mafatlal sir. That is, if we talk about the drug delivery, so shall we focus on the nano scale robotics, or is it some nano scale
It
robotics?
depends. Yeah. Yeah, it depends upon at what level or what kind of quantity we are working on. If there is smaller quantities on which we need to work, or there is some kind of uh, detection of that from that drug we need to perform by that sensor inbuilt in that robot, then we might look for nano sensors, nano robots. But nano robots are something which are not very much mm, uh, developed till now. So any normal robot, it can have nano components inside it, nano sensors and nano actuators, and they can perform the similar task.
Okay, thank you, Manish sir. Is there any other question from participants? Kindly don't forget to fill the feedback form.
Yeah, there is something asked by Vikrant. Arduino is used for IoT. Arduino used for both IoT based robots and non IoT based robots. It's useful for both. So you can you can use it in both situations. And it's the beauty of Arduino that it's an open source. Open source means that people who are working on Arduino, they give their input to develop this software further to make it well performing one. So on the basis of that, this software is continuously improving itself, right?
So, in continuation with that, Mr. Vikrant is also asking that what about software robot?
Hmm.
He is also
What about
asking that
software?
what about software robot? I think which you have
So
already covered.
there is no terminology named as software robot. The terminology which we use, that is robot which is virtual, which is used to control certain things, that is known as virtual robots, right? So we have already covered that in our presentation.
We got one question from Ms. Jyoti Grewal. What should be the PhD topic if we consider AI?
Sir, for PhD, which topic is best for AI? That depends upon your past study background as well as your expectations. On the basis of that, PhD doesn't mean that we need to change the world, do something which can change the world. PhD means we need to explore something which is in one form or another form existing but not known to the world. So we can work in any kind of thing, no issue. This decides on the past background, on the interest of ourselves, that which kind of things we are finding something fascinating. So on the basis of that, we decide that what should be the theme on which we should work in PhD.
Yes, sir. I would request participants if you feel like your questions are, you again need to engage the section or you again need the elaborations, you can definitely unmute your mic and go ahead with that. So, are there any questions from participants or the faculties? Kindly fill the feedback form. Uh,
And thank you all for
yes.
listening
So,
us.
yeah. Shall we conclude, sir? Manish, sir?
Yeah. Yes, ma'am. Please.
Yeah. So, thank you, Manish, sir. Definitely, the field of robotics engineering is booming, and it is a demand for next generation. But on the contrary, as you already covered this thing, that we are working on something very hard that is going to cost people's job. So that is definitely there. But advancements are and will always be the need of generation. So thank you so much for this informative, compact, and engaging and interesting session. I would thank to all the participants, faculties, and for being here and for encouraging us. We would look forward to have you in the remaining two more sessions of this career striker. So be there. And at last, I would definitely like to thank GSFC University for giving us this opportunity. Thank you to Saurabh sir, Santosh sir, Nishit sir, and of course all the participants. Without you, this could have been definitely not possible. Thank you so much once again to all of you.